about density today. Density, you say? What is density? It's the mass of an object in relative to its volume. I bet you don't remember that from your science days. Well, we're going to test that using oranges. Now, oranges are not grown in Indiana, but it's a great way to show you what density does. We're going to take a clear bowl and fill it with water. I'm just using regular tap water today. That looks good enough for our oranges to take a swim. If I put these oranges in a bowl, what do you think they're going to do? Sink or swim? Let's find out. Wow, they're floating. That is so cool. Now, I'm thinking, how do we make them sink? Well, let's test that. Let's take an orange out and peel it. I have my handy dandy Tupperware peeler, one of those great giveaways from the early days of my marriage and Tupperware parties. Oh, smell the fragrance of that orange as it squirts. Oh, it's delicious. Oranges are grown in California primarily, and we ship a lot in from Mexico. Okay, I have our orange peeled, and we're going to put it back in the water. Let's see what happens. Oh my gosh, our orange sank. What caused that? Well, this orange rind is filled with tiny air pockets, and that gives it buoyancy. So we remove the rind, it increases the density of the orange. This orange will float because of the air pockets. Isn't that a fun concept to learn about density of an orange? Have you ever seen corn pop? Well, of course you have. We've all enjoyed a popcorn snack at the movies or at home on a Sunday night. This time we're going to see corn hop, not pop. To do this experiment, we need water. I'm going to fill my container about half full. Oh, that looks perfect. Then to that, we are going to add some food coloring. How about yellow? Doesn't that remind you of great buttered popcorn? Super. And now we're going to add 2 tablespoons of baking soda. I made sure to buy a fresh box, so it would be perfect for this experiment. Now we're going to add a few kernels of popcorn. Let's say about a tablespoon's worth. There they go. Anything happening yet? I don't think so. We need a catalyst. Let's use vinegar. Vinegar is citric acid. We're going to use 1/4 cup of vinegar. Woo! I love the bubbles! Now let's see what happens to make our corn hop. Oh, some of our corn is already floating. Oh, I hope you can see through the camera that our corn is rising to the top, and it pops and it's going back to the bottom again. This will continue for about an hour. That is because we have carbon dioxide made from using the vinegar and the baking soda. What a cool experiment to do with your kids at home. Watch corn hop. Today we're going to find out what effect does vinegar or an acid have on an eggshell. Our eggs have been soaking for 4 days. 1 egg in vinegar, 1 egg in water. Which is which? Let's find out. We'll open the first container, pour out the water, and lo and behold, I have an egg. Can you hear it tap? That egg hasn't changed. That must have been our water. Let's see what this one did. Open the jar. Ooh, it's all fuzzy in there. Pour it out and, oh my gosh, look at that! We have no shell. We've made a rubber egg. Isn't that exciting? Okay, if you look really close, you can even see the yolk through the membrane. What happens is the vinegar acts as an acid on the calcium carbonate, which is what makes the eggshell. I like to tell children, this is what happens when you don't brush your teeth. If you drink a lot of sodas and the acid in the sodas, the carbonation, will eat away the calcium of your teeth. Be pretty hard to eat a nice steak or a raw carrot or a juicy red apple with teeth that go squish. I can bounce this egg, but for the sake of making a mess, I will refrain from doing that because it could break, but it could bounce. What do you say? Shall we try anyway? Let's do it. Oh my gosh, if you did that with a real egg, with the shell intact, it wouldn't do that at all. So, remember children, brush your teeth, or these will be your teeth in the future. Uh-oh, I've done it again. I boiled eggs, stuck them in the refrigerator, and they got mixed up with the regular, non-cooked raw eggs. I don't know how to tell the difference. Do you? Well, I have a secret to show you which eggs are raw and which eggs are boiled. Let's try it. We're going to spin the egg. Ooh, that one doesn't spin very good. You know why? That's a raw egg. Because the contents of this egg inside is not solid, it will not allow the egg to spin. Let's try this one. Wow! Look at that egg go! This for sure must be a hard-boiled egg. The solid contents inside will allow that egg to spin for a very long time. Let's try this one. Not a spinner, it's a raw one. Scrambled eggs for breakfast for sure. Okay, last egg, let's try. Wow, another spinner. This is great. I know that this can go on top of Mark's salad for lunch. Now you know how to test raw eggs from hard-boiled eggs. I'm ready to bake in my kitchen today. I'm going to need some eggs. I probably am going to need several. So I'm going to get into the refrigerator, pick up my eggs, and oh no! What a mess! Who hasn't done this at one time or another in their kitchen? Maybe it even rolled on the floor. Gosh, I hate cleaning this mess up. You just can't grab the egg. Oh my gosh, what a mess. I can tell you how to fix that problem in a hurry. Get some table salt. Pour table salt over your egg mess on the counter or on the floor. And just wait a second. The salt reacts with the egg and makes this egg perfectly able to be picked up. Yolk and all. Look at that. Plop, in the trash it goes, and all I have to do is clean up the little bit that's left behind. What a neat, clean way to get rid of a potential mess. Thanks for coming. I saw in one experiment earlier that eggs do break. Well, I'm going to try to break this one with my bare hands. Take your egg, place it between your palms, and squeeze as hard as you can. Oh, wait a minute. We have the advantage of a sink. Let's use it. Oh my gosh! Why won't that egg break? Oh! Well, it just won't. Now, if I squeezed it side to side, in a heartbeat this egg would break. But from end to end, the dome structure of the egg allows it to be super strong. This is a great experiment to do with your mom and dad, but make sure they do it over the kitchen sink just in case, because if your egg has a crack, it will break. This is why they build super domes and football stadiums with a dome. It allows the weight of the ice and the snow not to impact the roof of the building. Let's do another experiment that shows how strong eggs are. The strength of our eggs. 6-pound book, 4 eggs. Voila! Let's make it 12 pounds. Success again! Should we try 18? Still no cracks. Here comes 24. Now we've got 1, 2, 3, 4. We add a fifth. 5 times 6 is 30 for all you mathematicians. 30 pounds. Still no cracks. Let's go again. 30. Oh, 36 pounds and we're out. But 36 pounds is what that egg was able to withstand from weight. Thanks for playing along. All right, have you ever thought to yourself, gee, I wish I could get an egg in a bottle? Well, maybe not, but I'm going to show you how it's done. We have an empty bottle and we have a hard-boiled, peeled egg. Ugh, gosh, it's just not going to fit. Well, I think I have a way to do this. Being married to a volunteer firefighter for 27 years has given me some insight about fire and what it needs to breathe. Just like we do, it needs air. We're going to light these candles. If you are under the age of 12, you should never use a lighter. Remember that, children. All right, we've got them burning brightly. We're going to take our bottle, put it over the candles, and watch what happens. Look at that. It sucked the yolk right out of the egg. That's because a fire needs oxygen to breathe. And when the fire took all the oxygen out of the bottle, then it reached for more oxygen, which was outside the bottle. Okay, today we are going to do an experiment with milk. You're going to have to trust me. This is whole milk with a red lid. This is 2% milk with a white lid. 2 plates, a bottle of dish detergent, and some food coloring. That's all we need to get this project started. We're going to put some whole milk in the plate on my left. Just enough to cover the bottom ought to do it. Now we are going to put 3 drops of food coloring in. Excuse me a moment. I think we'll use 3 different colors for this experiment. How about red, green, and blue? Okay, just a drop. 1, 2, and 3. Now, we are going to use dish detergent and my handy dandy little stopper. We'll suck some of that up. And now we're going to put soap on top of the food coloring. We only added the food coloring so you could see what we were doing today. Milk is made of protein, minerals, and fat. Wow! Can you appreciate the sight of that milk swirling around? That's because the dish detergent is attracting the fat molecules. And so it gathers the fat molecules out and then it disperses them. And you have a tie-dye milk experiment. Now, that was whole milk. Let's see what happens with our 2% milk. 2% milk just means it has 2% milk fat. You can also do this experiment with skim milk, half and half, or heavy whipping cream. All right, 3 dots. Oops, different colors. I almost made a mistake. There we go. And our handy dandy little dropper. Woo! Look at that milk go. But as you can see, it doesn't go as far with the colors as does the whole milk. That's because there's more fat in the whole milk. Let's try that experiment again. Let's just add more food coloring. We'll mix it up so the colors aren't in the same place to see if there's any fat molecules left. Here we go. Nope, it looks like all of our fat molecules were displaced in the very first dropper with soap. We can try this one again. It's maybe getting a little bit bigger. We'll try it one more time to see if there's any fat molecules left. And a drop of soap. Whoop, we're all out. Not much happening there. That's how we tell the difference between whole milk and 2% milk. I hope you've had fun with our experiment today.